Hi everybody, my name is Mike Ryan, and for my objective in 2018 I was tasked with creating training material for the intercom system and the main applications that we use to interface with our intercom system. So today I'll be going over some basic functions in AZ Edit and RVON Edit. So first things first, when we open up AZ Edit, this is the main application we're going to use to program our intercom system. AZ Edit will generally try to connect to an intercom frame. There's a setting here in Options and Preferences that you can check mark Auto Connect at Startup. Most times this will be checked, but just good to know that you can disable it if you need to. It will attempt to connect to a frame based upon the communication settings we have here in Options Communications. In this instance, you can see we're using a network connection to connect to the frame, and these two IP addresses listed right here are the IP addresses of our master controller cards in our frame. So very important that we point this IP address at the proper controller card so that we can talk to the frame with no issues. So using a network connection and having the proper IP addresses in here with a good solid network connection, we can see that we are in fact connected to the frame. It says online here. You see two green LED status lights to indicate that we are talking to the frame. And you can also see here that the alphas have now been renamed according to our file that we have loaded. Oh, and speaking of loading files, how you would load a file is you use this button here called Send File, and when you do that, it will prompt you for a file. You go ahead and select it and hit Open, and then send those changes to the intercom. But in this particular case, I don't wish to do that right now. Another way to manually connect, once you again have these communications settings set up properly, we would go to Online and we would hit Connect here, or you can just hit Control G. So once you're in to the intercom, a few things to look at as a basic overview. This I/O cards page is a nice handy tool. This gives you an overview of all of the cards that are installed in the frame, which slots they're installed in, and which ports of the intercom frame are allocated to which cards. So you can see here that the majority of the cards in Victory's frame right now are AIO 16 cards, which are analog audio cards that handle 16 ports each. And you can see over here that we've allocated first 16 ports to the first card, and then the next 16 ports to the second card, etc. There's a tri-bus card because this tri-bus links the main intercom frame in the A unit to the M frame in the B unit, which is listed down here, frame 2, slots 1 through 8. There's a few AIO cards in there and another tri-bus to link between this one. You'll also see there's a MADI 64 card, which, you guessed it, handles 64 ports. So if we wanted to add a card to a frame, say for example we wanted to add an RVON card on this show, a couple steps we need to take care of. First, one, we want to figure out first which slot we want to allocate it to. Then you need to physically go to the frame, install the backplane first, and then once we have determined that the backplane is in place, we can go ahead and slide the front card in to the backplane in the slot that we've chosen. When you've done that, the intercom system will report that there's a card in that slot, and it's important to make sure you allocate ports to that card. So in order to do that, we want to go to Options, Port Allocation Table. In this hypothetical example, we're going to be adding an RVON 16 card into port 13. You can see here it says there's no card that's detected because there's no RVON card currently in Victory's frame. But if we had just installed one, then this would give you this warning wouldn't be here, and if we installed it into slot 13, it would show up here. I believe it'll show up here. If not, we need to make sure that we mention that it's an RVON 16, and in 13 allocate 16 ports to it. And then in this drop-down menu, we need to make sure we assign 16 ports to the card. And this drop-down menu will give you selection over the available ports in the intercom frame. You'll notice it only gives you 161 through 176 and 241 through 256 as options, because those two banks of 16 are the only two banks of 16 in the frame that aren't already being allocated to other cards. So make sure you allocate your ports and hit apply. Okay, so now that we've installed our RVON card into our frame in slot 13, we've allocated ports to the card. Just a friendly reminder to make sure that we set the IP address on that RVON card to match up with our system. So in Victory's case, being truck 14, that RVON card would get the IP address of 10.14.11.11. And using this icon here, which is, there's no RVON card, so I can't click it right now, but that icon will help you out, as well as status RVON connections, which is grayed out as well. So those two locations in AZ Edit will help you in the IPing process of the card. So I want to talk a little bit about MADI 64 card that we have in the frame right now. It's got 64 channels of available ports, 177 through 240, but we need to make sure that those are configured properly. So if we go over here to options and it's in status MADI cards. There's 3 tabs here that will help us in the configuring of the MADI card. So again, this is echoing the same information that the I/O cards page is telling us. The MADI card that we have is in slot 12. The ports that are allocated are 177 through 240. And again, we know now that we can go into the port allocation table and change those ports if we needed to, but all looks good for this case. Keep scrolling to the right, we can see a little bit more information about the card, type of card. There's options for reference as well on the back plane of the card. If we wanted to feed it reference or word clock, sample rate, and link mode. Now link mode is important because there's multiple options for connectivity on the back of the MADI cards. There's 2 slots for fiber interface via SFP, and there's also an option for coax as well. So you'll need to tell the card which link you're planning on using, and that's how you select it in this drop-down menu here in this tab. So card status shows the status of our link. Coax link is good, which means it sees the stream. Status is okay. MADI channel mapping. This tab is important because I've seen on some shows where on the MADI card we are missing a bank of audio, and I've actually come in here at times and seen that these channels aren't properly mapped to the ports. So just as a heads up, it's something that we need to make sure of when we're moving MADI cards around between frames and installing in larger shows. Make sure that you have the channels mapped properly to the ports and to the alphas, 1 to 1, 2 to 2, 3 to 3, etc., all the way down the line. In this case, it's a MADI 64 card, so we want to map all 64 channels to the proper ports. So now that we've talked about a few different types of cards, how to install cards and how to configure cards, I want to spend a little bit of time on the KPs section here, showing a few little useful tools. KPs portion of AZ Edit is where we can program key panels. We can search here by the port number. All the alphas are listed alphabetically. For the sake of this example, I'm going to use TX, which is the alpha corresponding to the engineering EIC KP32 panel, which we can also see here is port 105 in the system. Over here, if we needed to change the type of key panel, we can hit edit and we can change that if we wanted to make it a KP12. If we were going between KP12s and 32s, we could do that here. A whole lot of options here. But generally, KP32s and 12s are what we use most of the time. That's where we make that change if we need to. If we wanted to take this set here, copy it over to another panel, that's very easy to do, and we can do it right here from this page. All we need to do is go over to Edit and click Copy, or a hotkey is just Control-C. And then we move over to the next panel that we want to copy this set onto. In this example, we'll use a B unit panel, port 268. And simple as Control-V or clicking Edit, Paste. And then you can see here the panel set from the EIC position has now been pasted onto this panel. Now, all of these changes are highlighted in yellow, and that's because the AZ Edit is telling you that there's changes that are here, but they haven't yet been sent to the intercom. They haven't been uploaded to the intercom. So in order to actually make those changes happen on the panel, we need to go over to this Activate button. Click that button, and it'll give you a review of what changes you've made. And then if you wanted to execute these changes and send them to the intercom, then we click Send. But in this case, I don't want to do that. That's how you would take care of it. Any changes you make that you decide, never mind, I want to go back to how it was, we can click this Abort button, and it'll just revert back to the original port 268 set here. Alright, so another useful tool here in AZ Edit is the Search and Replace function. This allows you to search for ports in the system, PLs, IFBs that are in use, find out where those ports are being used, and replace them with other ports. So that's very helpful if you need to make changes to ports and you've already started configuring panels. It really helps make your life a lot easier. So in order to do that, we need to go in here to Edit, search for key assignment, or you can just hit Control F. And then this right here allows you, this is with a window, you can search for a particular port. In this case, I'm going to search for the B unit maintenance KP32 panel and replace it with the A unit engineering panel, which is alpha TX. So select what you want to search for, select what you want to replace that port with, and then it gives you two options. You can either selective replace, which will list all the locations that alpha is being used. So we know that the B unit maintenance KP32 alpha port is on the TX panel, and the A unit is also on the B unit QC KP32 panel. So you can go to those panels, or you can just individually replace them. So I'm going to replace it on the B unit QC panel here, and the system will replace port 270 on the B unit QC panel with port 105. Perfect, so let's go take a look at it. QC. And see, it used to be here on this talk key. Now we have two transmissions, or we have two A unit engineering panels, so I think I'm going to normal that up now. Back to B unit MNT. Make that change, and we activate that. Because remember, if it's highlighted yellow, there's a change that hasn't been synced up with the intercom. So let's go ahead and send that change back to the QC panel. And there you have it. That's how you use search and replace in AZ Edit. Okay, so we're going to use a program called RVON Edit to program our external RVON panels as well as any RVON IOs that we want to use. So in order to connect these two external devices, we need to go through an RVON card. And so this IP address right here is the IP address of the RVON card on Victory, although it is not currently on the truck, which is why you see this X. That X just tells you that the device that's in this list is not on the network. The RVON can't see it. If the device was on the network and talking properly, then you would see a green check mark. So that's another thing to look for when you're programming these. You won't be able to actually configure the devices if they're not reachable. But for the sake of this tutorial, I can still go through and show how it would be done. So in this case, this is our RVON card. So for the sake of being clear as possible, I'm going to rename this Victory RVON 16 card. So say we wanted to add an RVON IO. We have one here in our devices, 10.14.19.41. Hypothetically, if we wanted to add this RVON IO to our system, we need to take a few channels off of this RVON card. And in order to get this to work, we need to point those channels on this RVON card at this RVON IO and vice versa. The two need to talk to each other. They need to be pointed at each other. So in this example, I'm going to take these three channels on this RVON IO, and I want to point these three channels at the first three channels on this RVON 16 card. So the first step in doing that is to go to the RVON IO here in our devices, and we want to type in the destination IP address. It's simply asking, where do you want me to look? And in this case, we want to tell the device to look at the RVON 16 card. So we type the IP address of the RVON 16 card, which is 10.14.11.11. And you notice when you do that, it actually auto-populates with the destination description, which is helpful. So let's type that again on channels 2 and 3, since we want to use all three. And so now we see that it's auto-populated on all three channels. Great. One thing to look for that's very important is you need to make sure that this destination channel row here matches up with what you're doing over here when you're configuring on the card. This is simply saying this destination channel is pointing to these channels on the card. So for this sake, since we're using the first three channels on the RVON IO to talk to the first three channels on the card, then the channels will just be 1 to 1, 2 to 2, and 3 to 3. So we need to make sure that on the RVON IO, we program them as such. So the RVON IO configuration is done on this end. Next, we want to program the card to talk properly with the three channels on the RVON IO. So very similar process. We type the destination IP address of the IO into the channels on the card. So that would be here, 10.14.19.41. And again, it auto-populates. Great. It even says destination type right here too. Again, we want to make sure that these channels match up with the channels that we've configured on the device. So in this case, it's 1, 2, and 3, matching up with 1, 2, and 3. Great. So that is ready to go. What we would do to activate that, ideally we'd have both devices with green check marks and talking, and then we come up here to the Send Changes button. We make sure we select the changes on both devices. Since we've configured on both devices, we've configured changes on both devices. We want both of those changes to be sent. Select them both, and you can click Send, and then it'll connect and send. But in this case, we don't have a card in the frame, so there's no connection. Alright, so say we wanted to, on channel 4, this RVON card here, say we wanted to add an extra RVON key panel. We wanted to throw one out by, I don't know, an LD position or something. So we wanted to throw down an extra RVON panel. What we want to do is a very similar process. We want to point the RVON panel at the card and vice versa. So you see there's a few panels over here that have been programmed in the past. We'll use this one, 10.14.15.50. Generally you'll use one of the RVON subnets like 13, 14, 15, or 16 on the trucks to program your panels. So programming the panel to this IP address, we want to make sure we point the panel at the card. So again, we type the card's IP address in the destination IP, and again it populates. Now here's where it gets, again, important to make sure you're paying close attention to this column here, destination channel, because you can see the card only has 2 channels that are programmable. Since we're using the first 3 on the card, we can't use channel 1, so let's use channel 4 for this example. So programming the panel, we've typed the IP address in of the card correctly. We can tell that it's accurate because this is auto-populated as an RVON 16 card, and it's showing the right destination description. Now we want to use channel 4 on the card. Great. So we're all done on the panel programming end. Go back over to the card, and then we remember we wanted to use channel 4, so we're going to go over here to channel 4 on the card, type the IP address of the panel in, which is 10.14.15.50 over here. Populates, and then we want to make sure that this destination channel corresponds with where we've made that programming on this end, and in this case it does. It's channel 1. If we had programmed it over here, then we would need to make sure this is set to channel 2. So we've pointed the card at the panel, and the panel at the card, and make sure our destinations match on as far as channels go. Last thing to do would be to again do that same process. These are just left over since we weren't able to change them before. We send the change when all these devices are online, and then you can tell the status of the card here. You can tell which channels are active. So in this case, we would expect to see all 4 of these light up green, and if key panels were up and running as well, we would see these as green as well, and we would expect to see channel 1, key panel 1, lit up as green. And that's how you know that the external panel is connected and talking, and it's the same with the RVON IO. As far as status lights go over here, you can tell with green LEDs. So that's how you program an RVON IO and an external RVON panel. Okay, so jumping back over to AZ Edit, I want to walk you guys through how to properly save an intercom file. To do so, we want to come up here to File, and there's 2 ways to do a save. There's the partial save, which if we click that, we can see here that we can select what we want to save. This is not the entire file, but rather a subset of the of the file, so we can save our port naming, we can save IFBs, PLs, key panel types, all these different subsets that we can change, even key assignment colors, all these little settings we could change, or we could save rather, and that's how you would save certain portions of a file. Just through here, you can save select certain ports, select all, deselect all. So the partial save is if you just want to save part of a file. That's quite self-explanatory. But if we want to just save the entire file, then all we need to do is come here and click Save As. Then Windows will prompt us for where we want to save it. So I'll use the team drive. I am on a Yes network show right now, so I'll save it in the appropriate RTS folder. Yes, Baseball, Toronto. It'll save as an Atom file. So click Save and it'll let you know that it might take a little while, but that's okay. We will save and let it do its thing. Depending on the size of the show, it could take a few minutes, but in this case, it shouldn't take longer than 30-40 seconds. Great, so that was successfully saved. Go here in our computer, we have the Google Drive open, and it looks like it is almost done uploading to the Google Drive. So we've successfully saved it. Oh, there it goes. And you can see it's now fully on the Google Drive. And if we wanted to re-upload that show, that's where we would locate that file. So I hope this was beneficial today. I hope that we learned a little bit about basics of AZ Edit, a little bit about RVON Edit, how to program RVON IOs, RVON key panels, and the basic functions on how to program some components of our intercom system. Hopefully this helped. Thanks for watching.